All right, so I have a problem where I want to find all the global max and mins, local max and mins on a closed interval. Now it's polynomial, so it's continuous everywhere. We should immediately think extreme value theorem and know that we have to check the endpoints. All right, the endpoints could be at x equals -3 and x equals 5. That could be a max or min. And the first thing I would do, guys, is take the derivative. Agree? And I'd say, hey, I know there are critical points when this puppy is equal to 0. So I see that the cube root, I solved this, is it the cube root of, 1/4? The cube root of 1/4, right, is a 0. So it looks like there's just 1 in here, okay? I don't think I have another value, okay? So that's the only 0, all right? So I have 3 values to check. This is not too bad this time.
Emily Mako, can you please report to the office, please, Emily?
So maybe a table method is the best one to do here. Now you notice this time I put -3 and 5 right at the ends of my table because those are the boundaries this time, right? And I know that the cube root of 1/4 makes the derivative 0. All right? So I plug in -3 into this thing. All right? -3 to the 4th is 81. Plus 3 is, minus 3 is 84, 85. So I get that this is 85. And then I plug in 5 to the 4th. 25 times 25 is 625. Minus 5 is 620. Plus. So I get some y values there. Now, could I plug in the cube root of 1/4 right now? Yeah. And find the max and min? Yeah. Is it a decimal? Absolutely. Is it ugly? It's pretty ugly, right? I might want to know if this is a max or a min, all right? And identify it, because my favorite notation at this point, guys, would be to change this function to f of x and say that this is f of the cube root of 1/4. How about that value? Isn't that the y value? Absolutely, but I still don't know if that's a max or a min unless I actually figure it out. I got a gut reaction that's probably a min, but I can figure this out by checking the signs on my first derivative. I could go to the left of it and the right of it, okay? Now, if I do, well, you could do the second derivative rule, right? Is that what you're thinking? And find out that this is a min. But I'm going to do it this way. I'm going to plug in -1 and see that this becomes a negative. I'm going to plug in +1 and see this is a positive. The justification here is it goes negative to positive. We're thinking to ourselves, it's decreasing to increasing. Oh, where are we at? We're at the bottom. So I would say this is a min, right, by first derivative rule. And since it's the only min, and I know that that's less than 85, do we agree? We can tell by simply looking that this is less than 85 when we look at this function, right? A decimal to the 4th power minus a decimal plus 1. I don't know what it is, but it's not much more than 1, right? So, or less than 1. I don't know which side, it's just small. So, here we are. Page. Now I just got to say it. So we have a global max of 621 at x equals 5. We have a global min of f of cube root of 1/4 at x equals cube root of 1/4. Guys, it's a combination of the first derivative rule, right? Finding our critical points and checking them. And along with the extreme value theorem, checking our endpoints. We always check our endpoints when there's endpoints. The justification on the local min is first derivative rule. And this is the extreme value theorem. Everybody keep practicing. This is a good warm-up problem. And on the AP, you're going to find a lot of things with endpoints. Every time there's endpoints on the AP, you got to check them.